Language is sequential. Music is sequential. Stock prices are sequential. Regular neural networks process each input independently. They have no memory. Recurrent neural networks solve this by maintaining a hidden state that carries information from one step to the next. Welcome to episode 15. Today, recurrent neural networks and LSTMs, the architectures that gave AI the ability to process sequences, understand language, and predict time series. A recurrent neural network processes data one step at a time, maintaining a hidden state that acts as memory. At each step, it takes the current input and the previous hidden state, combines them, and produces an output and new hidden state. The hidden state is like a compressed summary of everything the network has seen so far. The math is straightforward. At time step t, the hidden state h of t equals tan of wh times the previous hidden state plus wx times the current input plus a bias. The output at each step is computed from the hidden state. The same weights wh and wx are shared across all time steps. This is what makes it recurrent. RNNs have a fatal flaw, the vanishing gradient problem. When sequences are long, gradients get multiplied many times during backpropagation through time. If they shrink at each step, they vanish to near zero. The network can't learn long-range dependencies. A sentence like the cat, which was sitting on the mat that I bought last week. Finally. The RNN forgets cat by the time it reaches finally. LSTM, long short-term memory, solves the vanishing gradient with a clever gating mechanism. It has a cell state that acts as a highway for information to flow unchanged across many steps. 3 gates control what to forget, what to store, and what to output. The forget gate decides what old info to discard. The input gate decides what new info to store. The output gate decides what to reveal. The LSTM equations. The forget gate uses a sigmoid to decide what fraction of old memory to keep. 0 means forget, 1 means keep. The input gate decides what new information to add to the cell state. The cell state updates by forgetting the old and adding the new. And the output gate filters the cell state to produce the hidden state output. RNNs and LSTMs power many sequence applications. Machine translation converts between languages. Speech recognition transcribes audio. Text generation creates content. Sentiment analysis classifies opinions. Time series forecasting predicts stock prices. And music generation composes melodies. Though transformers have largely replaced them for language, they're still important. RNNs gave neural networks memory. LSTMs made that memory long-lasting. But both have a successor that changed everything, the transformer. That's next, and it's the most important architecture in modern AI. Subscribe.